So we'll be talking about the float data type in C programming language. Now the three standard floating point types that is available in C programming language is float, double and long double, right? And the relationship is that the set of real numbers that is supported by this float. So this float, if it is representing set of real number, then double and then long double, where we know the sizes are size of float is 4 bytes, for double it is 8 bytes, for long double it is 16 bytes in typical 64-bit architecture. So the relationship that it holds is the set that is float, the set of real numbers that is represented within this range of 4 bytes. So this float is subset of double. Again, this double is subset of long double. So that is the subset relationship that these three data types hold among each other. Now, the three floating point data types in the C programming language, as we stated earlier, are float, double, and long double. And the size that are constrained by this relation, that is the size of float on any day, it has to be less than equal to size of double, and this size of double has to be less than equal to size of long double. Now in typical architecture, size of float is 4 bytes, for double it is 8 bytes, and for long double it is 16 bytes. So in modern day systems, the floating point numbers are stored using IEEE 754 format. Now this is something that is out of our scope of discussion. So in some other module, we'll be covering that part if you are unaware of the fact, right? Now, so if you observe the literals, the floating point literals here, so if you observe this, if you observe these literals, in this I have just written the numbers as it is with the decimal point, right? This is the scientific notation, this is also written under the scientific notation, right? Now whenever you are writing the floating point number as it is without any suffix or without appending any letter, so it is by default treated as double type. And when you append an f, so that literal is categorized into the data type of float type, that is 4 byte. That means this one is representing 4 byte float type. And when you append this L, so this is indicating that it is of long double data type, right? So append F, it can be both lowercase and uppercase to indicate float, and append this L to indicate it is of long double. And if you do not append anything, so in that case it is treated as double data type. So you can observe here, I have printed the sizes of. So if you can observe here, I have used the compile time operator size of, and I have mentioned the data type. So this consumes 4 bytes, so the output is 4, right? Then size of long, so I should have written size of double here. Anyways, I'll show that. Okay, so size of double also, if you check, in this case long is 8, I'll show you for double, and for long double it is 16 bytes, right? So let me write the code to show you this. So what I'll do here, so here I'll be writing printf percentage z u for the size actually, and here I'll write size of float. So this will print 4, right? Similarly, for this will be for double, that is 8 bytes, and this one for long double. So now let me just compile and execute this. So if there are no compilation errors, it will go fine. And you can see after execution, it is for float 4, for double 8, and for long double it is 16. Similarly, let's say instead of this, if I write 5.6, then guess the output for this one. So this 5.6 is treated as double type, right? So for this, the output must be must be 8 bytes. If I write, let's say, the same number, but if I append f, both, it can be lowercase or uppercase. So in that case, this should result in 4 bytes. And for long double representation, if I write, let's say 5.6, the same number, but this time the suffix, or I'll append L over here, right? So in this case, if I compile and execute, so you can observe 8, 4, 16. So 8 byte, so this is of double type. 4 bytes, because this 5.6f is treated as float type, and for L it is long double type. Now the next concern comes that how can we print and represent these numbers. So you can observe, for representing float type, we are using the suffix f 3.14. For double, I'll just write the number as it is without any suffix or prefix, right, as a letter. And for long double, you can observe I've written a large decimal number over here, and I have appended over L. So in order to print float type, we use percentage %f. To print double type, we use this percentage %f again. And in order to print this long double format, we use percentage %lf. So if I execute this, so you can see, you can observe the output here. So since float has less precision, so therefore 3.14. And for double, I wanted to print all of them. So you can observe after 9, this 26535 is rounded off to 3. So that's the story about double. And for long double, you can observe we use this format specifier percentage uppercase LF. So these are the format specifiers for each of these data type, right? For double, we also use this lowercase LF sometimes. So that also should work, right? So that's the idea of how do you store this, how do you use these data types, how do you store the values, and how do you print them. So that's a brief idea regarding your floating point data type in C programming language.